friends, welcome you all to Think Maths. We are in class 10 Maths, chapter 6, triangles. So in this session, we are going to discuss about exercise 6.3, question numbers 9 to 16. Okay. So in the last session, that is in the last video, we discussed about the problems 1 to 8. If you haven't seen the video, so the link is in the description box. So just click the link and you can view the video. Okay. So now moving on to the problem 9. In figure, ABC and AMP are two right angles at B and M. So prove that triangle ABC similar to triangle AMP. So second half is CA by PA is equal to BC by MP. So what is given? ABC and AMP are two right angles. So where it is right angle? Angle ABC. So that is angle ABC is 90 degree and angle AMP is equal to 90 degree. So these are the things given. We have to prove triangle ABC is similar to triangle AMP. So now consider these triangles. So let me start the solution. So in triangle ABC and triangle AMP. So what is given? Angle ABC is 90 degree. Right angle. So right angle means it is 90 degree. So it is given that angle ABC is equal to 90 degree. Also angle AMP. So in this triangle, angle AMP is 90 degree. Angle AMP is 90 degree. So these two are equal because the reason is both are 90 degree. Okay, children. So next, if you check the triangles, in this triangle AMP, angle A is present. MAP, angle A is present. In this triangle ABC, angle BAC is present. So this angle A is common to both the triangles. So we can write angle A is equal to angle A. Common. So we have two corresponding angles are equal. Then we can say triangle ABC similar to triangle AMP. What is the reason? Angle similarity. So we have proved the first part. What about the second part? It is CA by P. Where is CA? So this line CA in ABC and PA in AMP. So these two lines and BC. So BC line and MP line. These two lines are proportional. So it is in triangle ABC and in triangle AMP. So these two triangles, the given lines are present. So we already proved that triangle ABC is similar to triangle AMP. Then what will happen? Their sides will be proportional. So CA. So last and first. So CA. So in this triangle it is last and first. So it is PA. PA will be equal to BC. So it's a 2, 3. Here also 2, 3. So BC by MP. So this is what given in the second part. So if these two triangles are similar, we get their corresponding sides proportional. So the reason is if two triangles are similar, then their corresponding sides will be proportional. So we got that ratio. Okay children, it is so easy. So moving on to the 10th problem. So what is the 10th problem? CD and GH are respectively the bisectors of angle ACB and EGF such that D and H lie on sides AB and FE of triangle ABC and triangle EFG respectively. So if triangle ABC is similar to triangle FEG, show that CD by GH equal to AC by FG. Second one, triangle DCB similar to triangle FHGE. Third one, triangle DCA similar to triangle HGF. So there are three parts we have to prove. Now what are all given? So it is given that there are two triangles ABC and EFG. So triangle ABC and EFG, in that D lies on AB and H lies on FE. Then what is given? CD and GH are bisectors. So bisectors, this line CD is the bisector of the angle ACB. That means this CD divides the angle C into two equal half. So both these angles will be half of angle C, and this angle will also be half of angle C. In the same way, this GH is the bisector of angle EGF. So then this GH divides the angle G into two equal half. So this will also be half of angle G, and this is also half of angle G. So these informations are given, and another important information is triangle ABC is similar to triangle FEG. So this information is very helpful to prove all these parts. Okay, so let us start the solution. So what is given? Triangle ABC similar to triangle FEG. So this is given. So then what we have? We have their corresponding angles equal. So angle A will be equal to angle F. Then angle B will be equal to angle E. Angle B is equal to angle E. Angle C will be equal to angle G. So this is because corresponding angles are equal in a similar triangle. So corresponding angles are equal. This is the reason. So now let us start the first part, proof. So we need CD by GH, AC by FG. So this looks like the sides are proportional in a triangle. In which triangle? So let us find out those triangles. So first to check the numerator, CD, AC. So where is CD and AC? So CD, AC. So if we join these lines, then we get the triangle ADC. Then check the denominator, GHFG. So GH and FG. So if we join this line, we get these two green triangles. Okay, so let us write those triangles name. So in triangle ADC and triangle FHG. So if we prove these two triangles are similar, then we will have this corresponding sides proportional. So first part we have to prove these two triangles are similar. So we know some angle values, and there are some details about bisectors of angle. So we are going to use that information to prove these two triangles are similar. So first we have angle A is equal to angle F. So we will name this as 1, and this is 2, and this is 3. Angle C is equal to G, angle B is equal to E, angle A is equal to angle F. So here we have A and F. So from this equation 1, we have angle A is equal to angle F. So this is by 1. So if we prove another corresponding angles are equal, then by AA similarity, we can prove the triangle similarity. So which angle can we take? So we have chosen the green triangle. So in this, if you check here, this angle. So we know about something about this half of angle C and a half of angle G. So let us write those angles. Which angle? Angle ACD. Angle ACD. Another angle is which angle? This G. Okay. So this angle can be written as FGH. So FGH. I am starting with F because angle A is equal to angle F. So here I am saying these two are equal because we have by equation 3 we have angle C is equal to angle G. So this is by third equation. Okay, so if we multiply both sides by half, nothing will change. So in maths, if you divide and multiply or multiply on both sides, if you follow those rules, the values will not change. So I am multiplying by 1 by 2 on both sides. So I am getting half of angle C is equal to half of angle G. So what is the value of angle ACD? Angle ACD is half of angle C. So we can write it as angle ACD. So what is the value of FGH? It is half of angle G. So it is FGH. So this is the reason these two angles are equal. Okay. So now we can say triangle ADC similar to triangle FHG. What is the reason? By angle similarity. Okay, children. So by angle similarity, we have proved these two triangles are similar. Then what happens? Their corresponding sides will be proportional. We need CD. So last and second. So CD. So in the same way, we have to take last and second. That is GH. So CD by GH equal to AC. So first and last. AC, first and last. FG. Okay. So we have shown the first part. So this is shown. First part over. So moving on to the second part. So second part, what we have to prove? We have to prove triangle DCB similar to triangle HGE. So triangle DCB. So we are taking the triangle DCB and triangle HGE. So where is this triangle? Triangle DCB and triangle HGE. So this brown triangle. Okay. So this brown triangle, we have to prove the similarity. What we have? So from this we have angle B is equal to angle E. So we have those in these triangles also. That is DBC and HEG. So this whole angle E and B is present. So we know that angle B is equal to angle E. So this is by 2. Okay. So in the same way, how we prove these two angles? In the same way, we can prove that angle DCB is equal to angle EGH. So I am saying angle DCB. Angle DCB should be equal to which angle? So this G. So G can be written as HGE. So these two angles are equal. So what is the reason? We have from 3 we have angle C is equal to angle G. So in the same way here we have to multiply both sides by 1 by 2. So if you multiply by 1 by 2 on both sides, the value will not change. So half of angle C is equal to half of angle G. So if you check here in the brown triangle, half of angle C is angle DCB. Half of angle G in brown triangle is angle HGE. So we proved that half of angle C is equal to half of angle G. Then we have angle DCB is equal to angle HGE. So we proved two angles are corresponding angles are equal. So then we have triangle DCB similar to triangle HGE. Okay. So we proved the second part. What about the third part? What are the triangles? Triangle DCA and triangle HGF. Which two triangles are these? DCA and triangle HGF. Green triangle. Okay. So this is green triangle. We already proved that these two triangles are similar because we already proved this because we have to prove their corresponding sides are proportional. So there is nothing to tell about this. So the same proof will be repeated here. So here what we have? We have angle A is equal to angle C. Okay, so this is by 1, first equation. Then what we have? Angle ACD is equal to angle FGH. That is angle ACD equal to angle FGH. So this is the same reason. Angle C is equal to angle G. Then half of angle C is equal to half of angle G. Therefore, angle ACD is equal to angle FGH. So, two angles are equal. Then, triangle DCA is similar to triangle HGF. So, what is the reason? Angle similarity. Okay, children? Can you understand? I hope you can understand this proof. So, moving on to the 11th one. What is given in figure? E is a point on side CB produced of an isosceles triangle ABC with AB equal to AC. If AD perpendicular to BC and EF perpendicular to AC, prove that triangle ABD similar to triangle ECF. So here what are the things given? E. So E is a point produced on side CB. So E is a point produced on side CB of an isosceles triangle. ABC is an isosceles triangle with AB. In an isosceles triangle, two sides will be equal. So here it is given that AB is equal to AC. So this is given. Next point, AD perpendicular to BC. So perpendicular means this line AD makes an angle 90 degree with the line BC. In the same way, EF perpendicular to EC means EF makes an angle 90 degree with AC. So if angle ADC is 90 degree, this angle will also be 90 degree. Okay. So because in a linear pair, if you add the angles, it should be 180 degree. Okay. So on both sides, we will have 90 degree. We have to prove triangle ABD similar to triangle ECF. So let me start the solution. So let us consider those triangles. What are the triangles? In triangle ABD and triangle, another triangle is ECF. What we have in this triangle? We have this triangle ABD. So in this triangle we have ADB is equal to 90 degree. That is angle ADB is equal to 90 degree. What is the another triangle? The another triangle is ECF. So this is another triangle ECF. So in this triangle, angle F is equal to 90 degree. So we can write as angle EFC is equal to 90 degree. So angle EFC is equal to 90 degree. Angle EFC is equal to 90 degree. So these two angles are equal. So both 90 degree. So we got one type. Next, what is given? AB is equal to AC. So given AB is equal to AC. So this is given. So if two lines are equal, then we have the angle opposite to equal sides are equal. So what is the angle opposite to equal sides? So we have AB. So the angle opposite to AB is C and the angle opposite to AC is B. So then angle B will be equal to angle C. Okay children, understood? So we have angle B is equal to angle C. So this is because angle opposite to equal sides are equal. So these are the things we studied in 9th standard which we were using here. So angle B is equal to angle C. So is it present in this triangle? Yes. So this is the angle B and this is angle C. Okay. So if we take the triangle, this white triangle ABD, so it is angle ABD. So this implies angle ABD in triangle ABD is equal to which one here? It is FCE or ECF. Okay. So this is equal. Okay. So angle ECF are equal. Okay. So we got two angles are equal. So what happens? Then we can say triangle ABD is similar to triangle ECF. So we should write it as ECF because angle B is equal to angle C, and what we proved? Angle D. So this angle D is equal to angle F. So instead of B we should write C, and instead of D we should write F. So the remaining is A. So for A, corresponding angle is E. Okay. So this is the order. You have to write the name of the triangle. So triangle ABD is similar to triangle ECF. So which is we have to prove. We have proved it. So we can write hence proved. Okay children. I hope you can understand. So moving on to the next problem. 12th one. What is that? Sides AB and BC and median AD of a triangle ABC are respectively proportional to sides PQ and QR and median PM of a triangle PQR. We have to show that triangle ABC is similar to triangle PQR. So both the triangles ABC, big triangle ABC and this big triangle PQR are similar. We have to show that. So what is given? Sides AB, BC and median AD of a triangle ABC are proportional to sides PQ, QR and median of triangle PQR. So let us write that. So let me start the solution. What is given? AB by PQ is equal to BC by QR equal to AD by PM. So this is given. So for AD and PM, so AD is the median and PM is also median. What do you know about the median? So median means this D is the midpoint. So what happens? This D divides BC into two equal half. So this will be half of BC and this will also be half of BC. So BD is half of BC and this is half of BC. In the same way, this is M is the midpoint here. So PM is the median, then M will be the midpoint. So this will be half of QR and this length will be half of QR. Okay children? These two lengths. So these are the things we know. So now we have to prove triangle ABC. So this full triangle ABC and this triangle PQR are similar. Now consider first two ratios. AB by PQ is equal to BC by QR. Okay, so these two sides are proportional. So what is the angle between these two sides? Angle B and angle Q. So if we show angle B is equal to angle Q, then we can say that triangle ABC is similar to triangle PQR by which property? SAS. So two sides and an angle is proportional. So we can use that property. So now we have to show angle B is equal to angle Q. So how we can show? Just what I am going to do. So just write AB by PQ. Okay. So AB by PQ. Okay. So next here BC. So I am going to divide and multiply by 1 by 2. So just multiply by 1 by 2 and divide by 1 by 2, which is equal to AD by PM. So what happens? This is AB by PQ, half of BC. So half of BC is nothing but BD. Okay. So BD divided by half of QR is nothing but QM. So QM equal to AD by PM. Now let me consider this ratio. Which lines are there? AB, PQ, then BD, QM, AD by PM. So which triangle we are getting? Triangle ABD and triangle PQM are similar. So we can write triangle ABD is similar to triangle PQM. As corresponding sides are proportional, we can say triangle ABD similar to triangle PQM. So side, side, side. So all three sides are proportional. So by this criteria, these two triangles are similar. So if these two triangles are similar, what we can get? We will get AB by PQ equal to BD by QM. So we got already. Then what we will get? What about the angles? So angles will be equal. So angle A will be equal to angle P. So we get angle A is equal to angle P. Then angle B is equal to angle Q. Angle D will be equal to angle M. Okay. So these things we will get. But what we need? We just need angle B is equal to angle Q. So which is here. Okay, so let us name this as 1 and this as 2. Okay, children. So now consider the triangle ABC. So in triangle ABC and triangle PQR, what are the things we have? We have AB by PQ is equal to BC by QR. So this is by equation 1. Also we have angle B is equal to angle Q. So angle B is equal to angle Q. So this is by equation 2. So AB by PQ is equal to BC by QR. So the angle between them is B and Q. So these two angles are equal. Then we can say triangle ABC similar to triangle PQR by which criteria? Side, angle, side. Okay. So by this criteria, these two triangles are similar. So it is so simple. So moving on to the next problem, 13th one. D is a point on the side BC of a triangle ABC such that angle ADC is equal to angle BAC. Show that CA square equal to CB dot CD. So a triangle ABC is given, angle ADC. So this angle ADC is equal to angle BAC. Angle BAC. So these two angles are equal. So D is a point on the side BC of a triangle. So this D is in such a way that angle ADC is equal to angle BAC. So we have to show CA square equal to CB dot C. So let us consider this triangle ADC. Okay, triangle ADC and this triangle BAC. Okay, bigger triangle BAC. So let me start the solution. So in triangle, so let me start with the triangle ADC and triangle BAC. So what is given? Angle ADC is equal to angle BAC. So this is given. So one angle is equal. So what about the other angles? So which one is common here? So let me check here. So here ADC, here BAC. So let me check this C. So is it common? So just check angle ACD. So this full angle is coming here ACB. What about in this triangle ADC? It is ACD. So in this triangle also this full angle appears. So we can say angle C is equal to angle C. The reason is common. So what we got? We got two corresponding angles are equal. Then we can say triangle ADC similar to triangle BAC. What is the criteria? Angle, angle. Two angles are equal. So by the criteria, angle, angle, these two triangles are similar. Then what will happen? Their corresponding sides will be proportional. So let me take CA. So CA is here. So I am going to take CA. So that is last and first. So CA, last and first. CB equal to, here CD is present. Okay, so let me take CD, last and second. CD, so last and second. I'm sorry. Last, here I took last and second. So here also I should take last and second. So it is CA. So if you cross multiply, you will get CA into CA. So CA dot CA equal to CB dot CD. CB dot CD. So CA dot CA is equal to CA square equal to CB dot CD. So this is the way we have to prove this. So we can write hence prove. So let me again explain. So it is given that angle ADC is equal to angle BAC. So we took the triangle ADC and triangle BAC. So these two angles ADC and BAC are equal. This is by given. So if we check these triangles, so C is common for both. So it is the same for both. So if we check this, it is angle ACA. So this full angle C is present in triangle ABC, and in triangle ADC, it is angle ACD. So this full angle is present in both the triangles. So angle C is common. So then we have by angle property, triangle ADC similar to triangle BAC. So if two triangles are similar, then we can say their corresponding sides are proportional. So corresponding sides are proportional. So how to write their corresponding sides? So here we need CA. So I am writing CA. So that is last and first. So last and first. In the second triangle we should write last and first. So it is CB. So CA by CB is equal to, and on the other side we have CD. So I am taking CD. So last and second. So last and second. In this triangle also last and second. So it is C. So we get CA by CB is equal to CD by CA. So on cross multiplying, CA dot CA is equal to CB dot CD. So CA dot CA is nothing but CA square equal to CB dot CD. So and we proved it. Okay children. So moving on to the next problem. What is given? Sides AB and AC and median AD of a triangle ABC are respectively proportional to sides PQ and PR and median PM of another triangle PQR. We have to show that triangle ABC is similar to triangle PQR. Okay, just listen carefully. So this is so simple. Just we have to apply the concepts we have studied in 9th set. So what is given? AB, AC and median AD. So AB, AC, median AD. in this triangle PQ, PR, PM. So these three sides are proportional. So let me start the solution by writing the given, that is AB by PQ is equal to AC by PR equal to AD by PM. So this is given. Okay. So what about the other things? This AD. So AD is median. So if it is a median, D will be the midpoint. So this will be midpoint means BC will be divided into equal halves by the point D. So BD will be half of BC and DC will be half of BC. So also PM is the median. Then QM will be half of QR and MR will be half of QR. So these are the things we know. Now we have to prove triangle ABC similar to triangle PQR. So for this I am going to draw a line. So this is given. We have to prove triangle ABC similar to triangle PQR. So to prove this, we are going to construct some lines. So from D, that is from the median, I am drawing a line parallel to AC. So this meets ABC, that is this meets the line AB at E. Okay, so here I draw line DE parallel to EC. So draw DE parallel to AC in triangle ABC. In the same way, from the median M, draw a line parallel to PR. So it meets at S. Okay, so draw MS parallel to RP in triangle PQR. So these are the things we did. Okay. So if this is so, in 9th standard we studied if D is the median, if we draw a line, so D is the median on one side BC. So D is the median on side BC. So if we draw a line parallel to the second side AC, this line which meets the third side. So where it meets E. So E will be the midpoint. So this is the converse of midpoint theorem. So just listen carefully. From a point on BC, one side BC, that is that point is median. So if we draw a line from a median on one side of a triangle parallel to another side, the point where it meets will be the midpoint on the third side. So this is the converse of midpoint theorem. So then E will be the midpoint of AB. In the same way, S will be the midpoint of PQ. So we can write E is a midpoint of AB and S is a midpoint of PQ. So the reason is by converse of midpoint theorem. Okay. So also we know that if D is the median and ED parallel to AC, then we have ED is equal to half of AC. So E is the midpoint and D is the median. If ED is parallel to AC, then we know that ED is equal to half of AC. So this is midpoint theorem. So this implies ED is equal to half of AC and this MS will be equal to half of PR. So this is midpoint theorem. Okay. So these are the things we know in 9th standard. Now we are going into the proof. Okay. So let me continue in the next page. So remember all those points. We will continue in the next page. So moving on to the next page. So far we have ED is equal to half of PC, SM equal to half of PR by midpoint theorem, and this is given. Now we have to do some calculations. What we have to prove? We have to prove triangle ABC similar to triangle PQR. So already we have AB by PQ is equal to AC by PR. Okay. So now we have to take some calculations. So what calculation I am going to do? Just I am going to divide and multiply. That is multiply by half AB and divide by half AB. So in maths, if you divide and multiply, the values will not differ. So here half of AB divided by half of PQ. So in the second half also I am going to multiply and divide by 1 by 2. So half AC divided by half PR. Keep this AD by PR as such. Okay. So now what is half of AB? Where is AB? So this E is the midpoint. So by converse of MPT, we proved that E is the midpoint. Then half of AB will be equal to AE. Okay. So AE divided by, in the same way we proved S is the midpoint. So if S is the midpoint, half of PQ will be equal to PS. So PS, which is equal to half of AC. So what is half of AC? It is nothing but ED divided by what is half of PR? It is nothing but SM. So keep this AD by PR as such. So AD by PR. AD by PM. Okay, I'm sorry. It is AD by PM. AD by this medians are proportional. So AD by PM. So now check these sides. AE. Next one is ED. Next AD. This triangle. In the denominator we have PS, SM and this PM. So in this triangle, all three sides are proportional. So then what happens? Triangle AED similar to triangle PSM. So which property? By side, side, side criteria, these two triangles are similar. So I am taking the angle, this angle as 1 and this angle as 2. So I am consider the angle EAD as 1 and angle SPM as 2. What happens to this angle? These angles will be equal because we have proved that triangle AED similar to triangle PSM. Okay, so then what happens? Angle A, not angle A, angle EAD. Angle EAD is equal to angle SPM. So we named it as 1. So angle 1 will be equal to angle 2. Okay. So this we can keep it as equation 1. So this is equation 1. So in the same way, if we draw a line from D to the side AC. So if we draw a line from D, the median, parallel to AB, then it will meet the third side AC. So then we will get a midpoint here. Okay. So in the same way in this triangle, if we draw a line from the median M parallel to PQ, it will meet PR at the midpoint. Okay. So if you follow the same procedure, we will get these two angles. This two angles 3 and angle 4. That is, if we follow the same procedure, we will get triangle ADC and triangle PMR will be similar. The same procedure if you follow, we will get these two triangles will be similar. Then angle 3 will be equal to angle 4. So we can write similarly. I'm sorry. So similarly, angle 3 will be equal to angle 4. So this is equation 2. So I am going to add equation 1 and 2. Adding 1 and 2. So if you add left hand side, this is angle 1 plus angle 3 will be equal to angle 2 plus angle 4. So what is angle 1 and 3? It is nothing but angle A. So angle A equal to angle 2 plus 4 is nothing but angle P. So angle A is equal to angle P. Okay. Now consider the triangle ABC and triangle PQR, which we have to prove similar. So what we got in these triangles, we already have AB by PQ is equal to AC by PR. That is AB by PQ is equal to AC by PR. So what is the angle between them? It is angle A and angle P. So we have proved angle A is equal to angle P. Okay. So then what happens? By side angle side property, these two triangles will be similar. So if we consider these triangles, we have AB by PQ is equal to AC by PR. This is given. And another one is angle A equal to angle P. So this is proved. So which we have proved. So then what happens? We will write here. Then triangle ABC will be similar to triangle PQR by which property? So these two sides are proportional. So AB side and AC side is proportional to PQ side and PR side. So what is the angle between them? Angle A equal to angle P. So then we have by side angle side property, these two triangles are similar. Okay children. So if you listen carefully, this problem is very easy. Just we have used the MPT midpoint theorem and converse of MPT. Just I will explain this very faster. What is given? The sides AB by PQ and AC by PR and AD by PM are proportional. It is given. We have to prove this triangle ABC similar to triangle PQR. So we have constructed some lines DE parallel to AC. So D is the median. So if we draw a line from one side of a triangle parallel to another side, it will meet at midpoint in the third side. So this is the converse of midpoint theorem which we studied in 9th standard. So then E will be the midpoint of AB. In a similar way, S will be the midpoint of PQR. So also midpoint theorem says that if ED is parallel to AC and D is the median, then ED will be equal to half of AC. So E is the midpoint and D is the median. If these two are parallel, then ED will be equal to half of AC. So in the same way, SM will be equal to half of PR. So these are the things we studied in 9th standard which we are using it now. So now moving on to the next page, we have all those things. So it is given and this we got by midpoint theorem. Now we are multiplying and divide from the first two ratios by 1 by 2. So half AB by half PQ is equal to half AC by half PR. So just we are taking this 2. So if we take this 2, half of AB. So half of AB is equal to AE because E is the midpoint. Okay, so since E is the midpoint, half of AB will be equal to AE. So in the same way, half of PQ will be equal to PS. So we will get AE by PS. On the other side, we have half AC. So half AC is equal to ED. Half PR equal to SM. So in the next one, we will get ED by SM. So keep this as such. So we got AE by PS. So now check the numerator. AE, ED, AD. So this is the triangle. In the denominator we have PS, SM, PM. So this is the triangle. So then we have triangle AED similar to triangle PSM by the side property. So if triangles are similar, their corresponding angles will be equal. So this angle will be equal. Angle 1 and angle 2 will be equal. So because AED is similar to triangle PSM. So this angle A and this angle P is equal, but it is not the full angle A. So it is just a part of the angle A. So I am naming it as 1. This part of the angle P is 2. So angle 1 will be angle 2 since because corresponding angles in a similar triangles are equal. In the same way, if we draw another line parallel to AB. So from D, if you draw a line parallel to AB, so it will meet the third side in the midpoint. So the point here will be the midpoint. In the same way, this point also will be the midpoint. So similarly, we can say then what happens? We will get triangle ADC similar to triangle PMR. So then this angles, angle 3 will be equal to angle 4. So this is in a similar way. So if we follow the same steps, we will get angle 3 will be equal to angle 4. So this is equation 1 and this is equation 2. Adding 1 and 2, we will get angle 1 plus 3 which is equal to angle A. So in the same way, on the right hand side we have angle 2 plus 4 which is equal to angle P. So we got angle A is equal to angle P. So now consider the triangle ABC and triangle PQR. What we have, it is given that AB, this side AB and this side PQ and AC and on the other side we have PR. So the angles between these sides are angle A and angle P. So which we proved angle A is equal to angle P. So we have by SAS, side angle side. So two sides are proportional and the angle between them is equal. Then we can use side angle side to prove triangle ABC similar to triangle PQR. Okay children, I hope you can understand this question very easily. So moving on to the 15th problem. What is that? This is an interesting one and simple one. A vertical pole of length 6 meter cast a shadow 4 meter long on the ground and at the same time a tower cast a shadow 28 meter long. Find the height of the tower. So what are the things given? A vertical pole. So it is a standing line, that is vertical pole of length 6 meter, cast a shadow. So this is the shadow BC. It is 4 meter long on the ground. And at the same time, so if the sun is here, okay, so this cast a shadow. Okay, the shadow is 4 meter for the pole and at the same time tower. So tower will also be standing straight. So it casts a shadow 28 meter long. We have to find out the height of the tower. So what we can find out from this? This is a vertical pole. So it makes a line which makes 90 degree with the ground. Okay, so it is a vertical pole. So it will be making 90 degree with BC. So tower. So tower will be standing straight. So this also makes 90 degree with this ground. So what can we say about another angle? So this angle C and angle R. What about this angle? Because here the shadow is calculated at the same time. So if the sun is here at that time, it will make the shadow with the same angle. So angle C will be equal to angle R. So the sun will cast a shadow with the same angle. Okay. So it is taken at the same time. So this angle make the shadow making with the ground. Okay. So the angle C will be equal to angle R because it is taken at the same time. So these are the things we can get from this information. So let me start the solution. So in triangle ABC and triangle PQR. What are the things we have? We have angle ABC is equal to angle PQR because both are 90 degrees. So angle ABC is equal to angle PQR, both makes 90 degree because pole is vertical and tower will be straight. Tower will also be vertical, so it will make 90 degree with the ground. These are the things we get. Next, angle C will be the equal to angle R. So this is because both the shadows are taken at the same time. So then this sun, which will be at the same time here, which will be at the same place here, it will cast a shadow with the same angle. So this angle C will be equal to angle R. So it will be in the same angle. The shadow will make an angle which is equal. Okay, so angle C will be equal to angle R. So what happens? We got two corresponding angles equal. Then we can say triangle ABC similar to triangle PQR by which property? Angle property. Okay, children. So why we are proving this? If we prove this, then their corresponding sides will be proportional. So we got some sides. By the corresponding sides proportion, we can find out the missing side. So what happens? Then their corresponding sides will be proportional. So AB by PQ. So AB by PQ will be equal to BC by QR. These two things are enough. No need to write AC by PR because AC by PR is not given. So what we have AB. So AB is equal to 6. 6 divided by what is PQ? PQ is the height of the tower which we need to find. So write it as PQ. What is BC? BC is 4. What is QR? It is 28. We need to find PQ. So just cross multiply. We get 6 into 28 equal to 4 into PQ. So what happens? Keep this PQ as such. And 4 is in multiplication. So bring it in denominator, that is in division. So 6 into 28 divided by 4. So it is 1 fourth, 7 fourths are 28. So what happens? PQ will be equal to 42 meter. So it is given in meter. So PQ is equal to 42 meter. So this means height of the tower. Height of the tower is PQ. So height of the tower equal to 42 meter. Okay, children. So simple. I think you can understand it easily. So moving on to the last problem of this exercise. So this problem is last for chapter. So chapter 6 is getting over. So what is this? If AD and PM are medians of triangles ABC and PQR respectively, where triangle ABC is similar to triangle PQR, we have to prove that AB by PQ is equal to AD by PM. So it is so simple. What is given? AD and PM are medians. So then D will be the midpoint. So AD is median. So then D will be the midpoint. So what happens then? If D is the midpoint, then it divides BC into equal half. So BD will be equal to half of BC and this is also half of BC. In the same way, M is the midpoint. So PM is the median, then M will be the midpoint. So this M divides QR into 2 equal half. So QM will be equal to half of QR and MR will be equal to half of QR. So these are the things we know, and it is given that triangle ABC similar to triangle PQR, which is an important information. So let me start the solution. What is given? Triangle ABC similar to triangle PQR. So this is given. Okay. So if this is similar, then we have their corresponding sides will be proportional. So AB by PQ will be equal to BC by QR equal to AC by PR. Okay. So this is because corresponding sides are proportional. So in a similar triangle, their corresponding sides will be proportional. So we got this. Okay. So now we are going to make some calculations. Okay. So just keep this AB by PQ as such. Now, just in maths, if you divide and multiply, the number will not change. Now, in this BC by QR, I am going to divide and multiply by half. So, half BC, half QR. Because just it will get cancelled, it will be same as BC by QR. So, keep this AC by PR as such. So, what is half of BC? It is nothing but BD. Half of QR is nothing but QM. Okay. So we will get AB by PQ is equal to BD by QM equal to AC by PR. Okay. So where is this? AB. So check the numerator. AB, BD, BD, AC. So in the denominator we have PQ, QM and PR. Okay. So just leave this side AC and PR. Okay children. So just leave the sides AC and PR. Just take only these two sides AB, BD, PQ, QM. So now consider AB by PQ equal to BD by QM. Okay, QM. So we are considering only these two half. Okay. So we can get AB by PQ is equal to BD by QM. Okay. So now what we have from this? We have angle B is equal to angle Q. So angle B is equal to angle Q. The reason is triangle ABC is similar to triangle PQR. Then this implies their corresponding angles are equal. So let me take angle B is equal to angle Q. So why we consider these two ratios and angle B is equal to angle Q? So just check here. AB, BD. So what is the angle between them? Angle B. PQ, QM. What is the angle between them? Angle Q. So we can consider this triangle. So in these two triangles, so in triangle, which triangle? ABD and triangle PQM. What we have? AB by PQ is equal to BD by QM. And also angle B is equal to angle Q. The reason is given here. So what we had? So the two sides are proportional and the angle between them is equal. So this implies triangle ABD similar to triangle PQM by the property side angle side. Okay children. So what happens then? Their corresponding sides will be proportional. What is their corresponding side? AB. So here AB is given. So take AB. So its corresponding side is PQ. So AB by PQ. On the other side we have AD. So first and last. So here also first and last. So AD by PM. So because corresponding sides are proportional. So if two triangles are similar, then their corresponding sides will be proportional. So we have proved it. What is given is proof. Hence proof. Okay children. I hope you can understand all the problems. So if you have any doubts, you can come at me. Thank you. Thank you for watching. Also, if you like this video, just share, like and subscribe and hit the bell button so that you get the notification whenever I upload my videos. Thank you for watching.